Well, okay, it's about time. First of all, can you hear me? Presume you guys can hear me. But like a double check. All right, can I get someone in the chat? If you can hear me, please say so. We can hear. Okay, thank you. All right, I think we can probably get started around now. A couple of people showed up in the last few minutes, but it's 5:05. 5:06. We should get started. A note about what we'll do today. So over each school year, there are, of course, several major math tournaments. Each of these math tournaments have different formats. So I know HMMT November was last week. This weekend we'll be having BMT, and if you're participating in BMT, I would hope you know what the format and schedule will be. Now, the point is a round that is in BMT that isn't in every math tournament. This round, a number of math tournaments does have a similar type of round, but not all math tournaments, is the power round. So today I'd like to focus on the power round. The other rounds of BMT are more or less standard, more or less similar to what you may expect in other math tournaments. The power round, there are quite a few math tournaments that do have the power round, but you may or may not have done a power round or many power rounds before. So I think getting the practice of a power round today would be helpful. So a power round essentially is you've got a, let's say, 5-page or so test. It's a group test. It's a team test, and the test is it's part. First of all, the topic of the test is a topic that's introduced in the test. So you'll read the test from beginning to end. You don't have to reach to the very end, but the topic is presented from beginning to end. And as the topic is introduced, there are questions about it which you answer. Some questions are just simply computational questions. Others do require justification. But some points to be aware is that, well, first of all, the questions are not sorted by difficulty. They're sorted by the order in which the topic is presented. The difficulty of the questions can be rather reasonably inferred from the point value. So generally, if you see something like it's a 1-point question, then it's something you expect to, you expect it to be an exercise. It's, the test instructions should specify whether which questions would demand justification, and which questions are just fine if you give an answer with little to no justification. So that's what the power round is like. I believe you have 90 minutes on the power round, which means even though there are proof questions, and you do want to write up these proof questions in a good style, which is have your work be logical, be neat. Don't lose points on unnecessarily. Still, it's not exactly a proof contest because, well, one, there are a lot of questions, a lot of small mini questions that each should be, or at least most questions should not be as difficult as what you might expect on a proof contest. And also, budgeting your time is very important in the power round. don't spend too long on write-ups, and have good cooperation within your team. All right, so with these general remarks, I'll so let me I'll share my screen as well, but I would also encourage you guys to download the PDF I'm about to upload in the chat. So and what this file is 2013 ARML power round. And I'll share my screen as well. There we go. Oh, sorry. Let me send it to the wrong person. There we go. You guys should see it now. So I encourage you guys to download the file, open it up on your end. For reference, because I may not have screen sharing this whole time. So the power round I chose to do here is a power round from ARML. Generally, I think I may be incorrect, but from my experience, you should probably expect that BMT power rounds will be longer. After all, I think ARML power rounds are designed to take less time than BMT power rounds. So the BMT power round will be longer, and in general, it may or may not be more advanced. So oftentimes when it comes to ARML, the topic is more elementary, perhaps more easy to understand. You might expect something a little more difficult to comprehend when it comes to BMT power rounds. Nonetheless, I think doing an ARML power round would be, first of all, we could go through an entire power round reasonably within the time we have, and it's also good practice in terms of getting used to the format of power rounds without having something too difficult. Okay. This year's ARML power round is quite long. So I believe there are several ARML power rounds. Let me just, I'll be concise, but to explain. So there's a power round that is in the competition. So when you go to one of the 3 test sites, Las Vegas and Iowa and Pennsylvania or something, when you go to ARML in June, there's a power round, and this is the power round that was taken from the in-contest 2013 June power round, which, if I remember correctly, ARML teams are of the size of 15 members, and this is to be done in 50 minutes. So about the same amount of man hours as a BMT power round. But there are also other ARML power rounds throughout the school year. And those, I think, tend to be longer. Those are designed to be done by a team over the course of a week or so. If you want to get a good, take a look at least at other power rounds, a number of competitions do have power rounds. The BMT 41, SMT, CHMMC, PUMAC has one that is designed to be done over a week. So power rounds do vary in their difficulty and length. But all right, what I'd like to do today is get you guys involved. So this power round, looking through it, you can see that the problems are just, in fact, all of the problems are actually 1-point or 2-point questions. So in this case, you should expect that most questions are should not require that much justification. So I think it's a good choice for us to get people here involved, and we'll have you guys perhaps take turns and write up or just do each of these sub questions. All right, so I think some new people joined. I'll send the file again. for you guys. So this is the power round we're looking at today. Oh, sorry. Here we go. That's the power round. And what I'll probably do is I'll change my screen sharing to whiteboard, and I'll have you guys annotate on the whiteboard, work out the problems, and I'll comment and I'll explain if necessary. So, all right, now I'll pull up a whiteboard here. So you should open up the power round on your end. And okay, we'll work this through. So I'll first read the header that explains some of the material there, and we'll get started. So some flavor text, but there's also some math involved, some theory involved in what's being defined here. So in Armalopolis, every house is a positive integer, and the city hall's address is 0. However, due to the curved nature of the cow paths that eventually became the streets of Armalopolis, the distance d of n between house n and city hall is not simply the value of n. Instead, if we write n as 3 to the k times n prime, where k is a non-negative integer, n prime is an integer that's not divisible by 3, so we factor out all powers of 3 from n, then we define d of n to be 3 to the negative k. So, for example, d of 18 is 3 to the negative 2, which is 1/9, and d of 17 is 1. So notice that even though no houses in Armalopolis will have negative numbers, d of n is still well defined for negative values of n. So d of negative 33 is 1/3, because negative 33 is 3 to the 1 times negative 11. All right, we'll define d of 0 to be 0, and we'll also refer to houses and house numbers interchangeably. Also, the distance between house n and house m will be defined as, so d of m comma n is simply d of n minus n, d of their difference. So d of 34 is d of negative 1, which is 1. In particular, if m equals n, then d of mn equals 0. All right. Now, I don't expect you guys, or maybe you guys do know what the actual theory behind this is. Maybe you guys don't. I don't. You should not expect to come into a power round knowing the material that's in a power round. The power round is it's designed to be at least new to most people. So as a matter of fact, d of n is actually the p-adic absolute value. Hence we call it distance. There are a lot of properties about p-adic, but I think we won't be getting too deep here in this power round. So anyway, let's get started here. So start with 1a. Let's see, should I call on people, or would someone like to volunteer? Thank you. So yes, if you wouldn't mind just annotating on the whiteboard, just writing it on a whiteboard, that would be nice. I have to apologize. Yes, thank you. It's good to when you're doing power round, it's good to call out what problems you're doing and have a team captain keep track of who's doing what. Just as a note. I'll apologize today for I don't have a stylus pen with me, so writing will be inconvenient for me, but I wouldn't be writing too much anyway. All right, so div 6 equals 1/3, div 16 equals 1, div 72 equals 1/9, correct. Good, okay. 1B. Of the houses with positive numbers less than 100, find with proof, but just a bit of justification would be fine. The house or houses which is or are closest to City Hall. So 1B. Yep, 80. So house 81. That's correct. Once again, just if you can annotate, feel free just to annotate it on a whiteboard. So 1A. All right. 1B. It's house number 81. Right. Oh, there you go. There you go. There we go. Thank you. I don't know if it's just not showing up on my end or, okay, you're still typing. All right. And while we get to that, 1C as well, find 4 houses at a distance of 1/9 from house number 17. Ooh, let's see chat. Yes, 81 is correct for B, because closest distance would mean you want the largest power of 3, so 3 to the 4, 81. 1C, find 4 houses at a distance of 1/9 from house number 17. Typically, when you do a power round at the contest, you would want to read the instructions on top to be sure. But I believe generally the convention is if the question says find something, then an answer should be sufficient. Okay, you can put 4 examples on the whiteboard. Any takers? Very good. Let's see. I'll check to make sure. No multiple of 27. Good. Good. That's right. Good. Okay, and now 1D. Can you find an infinite sequence of houses whose distance to 17 gets progressively smaller? Good. Good. That's correct. Simply 17 plus powers of 3 would suffice. Okay, so that's your introduction to this distance, this p-adic absolute value. All right, now we'll a bit more terminology, more definitions coming. So we'll call the neighborhood of a house n, written as big N of n, to be the set of all houses that are the same distance from City Hall as n. So m is in the neighborhood of n if d of m equals d of n. And of course, it's not. You're not actually. If you were to plot this, it would not actually be, Euclidean would not satisfy properties of the Euclidean plane, but geometrically and linguistically, we'll call this as this circle centered at City Hall with a radius of d of n. So find 4 homes in the neighborhood of 6. So what? Oh, yeah, there we go. So 2A, we're on 2A. Find 4 houses in the neighborhood of 6. Three, 12, 15, 20. Good. These both examples are correct. Simply any house divisible by 3, not divisible by 9, suffices. Yes, very good. All right. Now, 2B. Suppose a house has d of n equals 1. Find 4 houses in the neighborhood of n. And I think while we're at it, we'll add also 2C. Suppose that a house n is a house with d of n equals 1 over 27. Determine the 10 smallest positive integers m in the neighborhood of n. So I'll mark. You can write out 2C over here. Oh, a note on power rounds that just came to my mind. Nothing in particular to do with 2B or 2C, but a good thing to know is, I believe, once again, it's confirmation. You should seek confirmation on this, but I believe it is the case that you can cite results that come before the problem you're working on. So you're working on a problem, you can cite a problem before, but don't cite a problem after, because oftentimes problems after could be a generalization of the problem before. 1, 2, 4, 5, correct. Those are in the neighborhood of 1. And 2C, the 10 smallest positive integers with whose neighborhood. Yes, you can use something that is proved in previous problems. Yes, correct. Thank you. Any takers on 2C? Find the 10 smallest, determine the 10 smallest positive integers that are in the neighborhood of n, where the distance of n is, or d of n is 1/27. Good so far. So this would be the 10th smallest positive integers whose largest power, for which the largest power of 3 that divides the integer is 27. $27, $54, $108, $135, $189, $216, $270, $290. Very good, very good. I think that's correct. Good. Okay. So at least to those of you who are answering, means you're getting the material, which is good. All right, 3a. So notice that d of 16 equals d of 17 equals 1, and the distance between 16 and 17 is also 1. Is it true in general that for all mn with d of m equals d of n equals 1 and m not equal to n, we have that d of mn equals 1? Is it true? Either prove it or provide a counterexample. Chat, let's see. You think you did this coincidence? Okay. Well, I personally have, I think, all or almost all of the Armel power rounds going back to 19, or probably to as back far as there were power rounds. So this was more or less a random choice that looked good to me. So coincidence. Yeah, but no problem. You can still contribute and get us rolling here. So I'll mark here 3a. Any takers on 3a? Mm-hmm. Yep, that is so 27 and 54, however. Let me first get to that. So 27 and 54, the problem is they don't satisfy d of 27 equals d of 54 equals 1. But your example, let's see, I think Julia's example of 7 and 10, 7 and 10 works, yes. So if someone doesn't mind, you can put 7 and 10 on the board and just write out what d of 7 is, what d of 10 is, and what d of 7 comma 10 equals. So if someone could write it on the board, that would be great. It's a glitchy for you. I'll write it. I guess. I am, however, not having my. It's okay. It's okay. So for reference, d of 7 equals d of 10 equals 1, but their distance between them is 1/3. Equals 1. And while we're at it, oh, yeah, n equals. Let's see. Which is this for? Can I?
It's for 3A. I'm trying to prove it.
3A. Oh, careful there, actually. Sure. All right. So if you try to prove it, here's what you would do. So d of m equals.
No, I'm trying to prove it wrong.
Okay. So to disprove it, then you just need to provide a counterexample, and that would.
Okay.
Yeah. So 7 and 10 is sufficient. That's good enough of a counterexample. Yeah. But good work though, because it will be useful on 3B, which is sort of a generalization of 3A. So while you're at it, you can attempt 3B. I'll write out 3A here. Okay, let's see. So n equals 3 to the, is it 3 to the c times a, and
it's k.
K, and k and r. Okay. N equals 3 to the k times a. Okay. M equals 3 to the k times b. So for 3b, that's your form of n and m, given that d of n equals d of m equals 3 to the negative k. All right, so the distance between m and n, very good, is d of their difference, 3 to the k times a minus 3 to the k times b. So what are all possible values? So it's a minus b times 3 to the k.
So a minus b can be either 1, 2, a multiple of 3, or anything like that.
Right. So your only condition on a and b is that they're not divisible by 3. So what can their difference be? It turns out it can actually be anything. So any value of a minus b is possible, which means that d of a minus b times 3 to the k is 3 to the, well, you tell me. What should it be, actually? Any value. So what about d of this a minus b times 3 to the k? What are all possible values of?
1 over 3 to the power of k, 1 over 3 to the power of k plus 1, 1 over 3 to the power of k plus 2, da, da, da.
Very good. So 1 over 3 to the anything greater than or equal to 3, greater than or equal to k. Yep, a greater than or equal to 0. Very good. All right. Very good. All right. So I'll clear. Let's see if I can erase and the left half of the annotations here. Okay, I can. So we'll keep 3a and 3b up here. Let me label this as 3b. All right. What about 3c? Suppose that d of 17m equals 1 over 81. Determine all possible values of d of 16. One, correct. If annotating is a bit slow, you can type it in the chat, I suppose. Could you give a quick justification of why 1 is the only possible value? So chat would be fine. (17 minus m is in fact divisible by 81, correct? Right, 16 minus m would be -1 mod 81, right? So it cannot be divisible by 3, and so it's d of 16m is just equal to 1. So 1 is your only possible value. Very good. Okay. So far so good. Yes. Equals -1 mod 3. I think. M minus. If you take the well, it depends on which way you take the difference, but it won't affect your value of. It won't affect your value of the distance. All right. I hope so far so good. Should be rather clear. There have been plenty of examples to work out the intricacies of this distance function. All right, now we're going to introduce in a triangle. So a triangle is simply well, just 3 points that are all houses of from Armalopolitan. And all right, so let's work out problem 4 as well. So let me okay, you guys have space down here. So You guys can start on 4A. And actually, while we're at it, let's see. Oh, I'll add 4B is here. 4B is here as well. So one of you guys can take 4A, and one of you guys can take 4B, and work it out. So 4A, show an inequality, show two inequalities about distances. And here, notice that we're looking at distances between pairs of 3 points. So for the first inequality, we're looking at the distance between 17 and 51. We want to show, essentially what we're trying to show is the triangle inequality, right? That the distance between 17 and 51 is less than or equal to the distance between 17 and 34 and 34 and 51. Same thing for the second inequality. We're also trying to show the triangle inequality for 1768 and 95. Okay, sure. So d of 1751, so that would equal, let us see. If d of 1751 is less than or equal to d of 1734 and plus d of 3451, then right, so d of 34, we're looking at their differences. D of 34 is less than or equal to d of 17 plus d of 17, which is true, because all these distances are 1. All right, what about d of 17 and 95? I'll copy what you have here, and very good. So that's 4A. Right, 1768 to 95 as well. So what about 1768 and 95? And if you want to jump ahead, think about the generalization, right? That would be 5C. Prove the triangle inequality holds for all A, B, and C. Which actually I should say 5C 5C probably follows from 5A and 5B. So if you want to look ahead, I think you should start with 5A and 5B before you get to 5C. So 5C looks like an instance of citing results from 5A and 5B. All right, can we get the values of d of 1795, d of 1768, and good. So d of 1795, we're looking at d of 68 is less than or equal to d of 51 plus d of 17. So the numbers should be 68, 51, and 17, which would be actually should be 1 is less than or equal to 1/3 plus 1. Would you agree with? Uh, 17. All right. So 95 minus 17. Ooh. Sorry, my bad. 78. You're right. Yeah. D of 7 is 78, 51, and 27. That's right. 650. Okay. Yeah. Agree. Sorry. That's correct. And we have once again, triangle inequality holds on 1768 and 95 as well. Okay, 4b as well. Takers on 4b. Ooh. Determine all values of c such that d of ac equals d of ab, where a equals 17 and b equals 68. So anyone on 4b? So all integers that are congruent to 2 mod 3. All right, so let's see how we get this. So d of AB is d of 1768, which is d 51, which is 1/3. Now d of AC equals 1/3 means that the largest power of 3 that divides c minus 17 is equal to is 3. That's okay. So let's see what we have in the chat. All integers that are congruent to 2 mod 3. You have to be careful there because, well, some numbers don't work. The difference between c and 17 has to be a multiple of 3, but not a multiple of 9. So Julia says, isn't it numbers of the form 17 minus 3k, where k is an integer less than or equal to 5? Well, for, c does not necessarily have to be less than 17. Or right, so what it should, all right, so what it actually should be, so is we have c minus 17 is, okay, so I'll use the this notation. It's called v sub 3. And what this simply means is it's the exponent of the largest power of 3 that divides c minus 17. Okay, so the exponent of the largest power of 3 that divides c minus 17. And this must equal 1. All right, so the answer is actually, c does have to be positive, yes. Well, does c, well, okay, I suppose we're not restricting c to positive numbers. Well, we're mostly working over positive numbers, but d is still defined over negative numbers. Okay, so we'll include C negative as well, but note that C can be larger than A, C can be less than A. So that's all fine. All right, and so the solution classes is actually some residues modulo 9. So you need the difference to be 3 or 6 modulo 9. That way it's divisible by 3 and not divisible by 6. Not divisible by 9. So the solution classes are 17 is equal to negative 1. So we've got numbers that are 2 mod 9. And you've also got numbers that are 5 mod 9. And those are all your numbers that work. So C equals 2, C equals 5, they both work. Okay, so and those are all your numbers that work for 4B. Yeah, so you do want to be careful when you're doing a power round. You don't have to rush in. When you're in the power round, checking is always a good thing to do. It takes far less time to check than it does to write it up. Yeah, no problem. I'm just giving you tips for tomorrow if you're going to BMT tomorrow or any power contest that you may be attending in the future. Don't be sorry about mistakes, by the way. You learn from mistakes, but when you're in the contest, if you find yourself not having nothing else to do, then checking is a very good idea. All right, now problem 5, and the point of problem 5 is we aim to derive general properties about distances between points on a triangle. So distances between pairs of points where these points come from a set of 3 points. All right, let me erase what we have here. I suppose I can, well, okay. I suppose I can erase by clearing an area, but I'm not sure how. Let's see, are we? Oh. Okay, clear. 5. And I'll write out 5. Let's see. 5A, 5B, 5C, 5D. Okay, so I'll write out 5A, 5B, 5C, 5D. Feel free to take on any of the questions. Just be aware that some of these questions may expect you to reference a sub-question above. So you are more than welcome to do that. If, say, you're working on 5C, you can reference 5B. You don't have to rewrite the proof of any proof that is above. And I think in the power contest, this is something that I'm less sure about, but I believe you can still reference a problem that you didn't actually solve as long as it's above. But not sure how much you should take my word for. Could take a pinch of salt. So first of all, prove that 5A is prove that the distance between A and B is less than or equal to the max of D of A and D of B. Chat is also fine if annotation's not working very well for you. And it's a free for all. Take any of these sub questions that you want. or what we can actually do is mimic a real power contest a bit more. We can have people call out. So you can, if you want to take a problem, then you can say so into chat right now. No worries if you don't end up solving it. You'll have backup as well. So, but let's have someone take 5A right now, and someone take 5B, someone take 5C, and someone take 5D. So any takers? Yeah, just ooh, let's see. All right, you can do 5A. Oh, sure. No problem. No problem there. Yeah. So just a reminder, B and C, and well, and D as well, reference, you do want to reference problems before, so some problems earlier. It will keep your write-up short, and there's really no need for redundancy. A lot of the learning value of this is seeing how one result implies another result. So even if you find a more complicated way to say just derive 5B without 5A, I think it's still worthwhile to find a more direct or a simple justification of why 5A implies 5B. Okay. Okay. Can I uh um ooh, okay. Also, if someone's working on 5B or 5C or 5D, because I don't see or no one in the chat has said they're working on 5B or 5C or 5D, but if you're working, feel free to tell me DM or a direct message or just or public message. Either's fine. But um, let's see, 5A. So all right, so there's a second case. All right, but so A equals 3 to the n times x, B equals 3 to the n times y. Case one, m is not equal to n. Without loss of generality, you can assume m is greater than n. Then the max of d of A and d of B is equal to 1/3 to the n. That is correct. So the distance between A and B is 3 to the n times x minus 3 to the n times y, which is 3 to the n times 3 to the n times 3 to the n minus n times x minus y. 5b, very good. All right, so let me first paste what we have for 3a, 5a. Text. Let's take a look at this. All right, so yes, very good. So we can let a equals 3 to the n times x, b equals 3 to the n times y, and if m is those are okay. That's your case. Very good. So if I could give a comment though, you can actually avoid casework here. So what you can actually do is okay. So the way to avoid casework here, which is by the way, casework it's fine. I'm just showing a slightly more concise way of slightly more concise argument. But case two, let's take a look. If m equals n, then we have the distance between A and B is the distance or d of 3 to the m times x minus 3 to the n times y, which is 3 to the m times x minus y, which is 1 over 3 to the n times 1 over the v3 of x minus y. Very good, all correct. And since the second part is less than or equal to 1, correct, then d of ab is less than or equal to max of d of a, d of b. Very good. So let me show you how we can actually combine these two, I think. So we'll take out the case. Without loss of generality, we'll assume that m is greater than or equal to n. So max of d of a and d of b equals 1 over 3 to n. That is correct. And the distance between a and b is d of their product, d of their difference, correct, which is equal to d of 3 to the n times the 3 to the m minus n, I'll put parentheses here, times x minus y. Now, all you need is that all you need is you want this to be less than or equal to 1 over 3 to the n. And that actually just follows from the fact that this whole thing here, if you can see my highlight, is divisible by 3 to the n. So the fact that it's divisible by 3 to the n means the largest power of 3 that divides it is at least n. And so, yeah, d of it is less than or equal to 1 over 3 to the n. So, yeah, so, all right, 3 to the n divides a minus b, so d of a b is less than or equal to 1 over 3 to the n, which equals max of d of a, d of b. But very good though. What you've written here is very useful though for a upcoming problem. So savor what you have. I'll just put the more concise version up here. All right, we also have 5b. Very good. Let's take a look. So the max of let's take a look. So max of d of a, d of a, d of c is less than or equal to the max of d of a, d of b, and d of c. That is clear, correct? Okay, so since we choose the maximum of the two sets, on the left it may be d of a or d of c. Let me just think. So d of a c is less than or equal to max of d of a, d of c. But on the right, it can get d of a, d of c, d of b, which gives us the last case. If I'm understanding you correctly, though, I think this might be an issue here, which is that it's an issue that can be fixed actually with some of the more details that Julia gave, but I think just the problem statement of 5a is insufficient here, and I think the issue here is, so I'll write out, we've got d of ac by 5a. We know this is less than or equal to max of d of a, d of c. All right, that's okay, because d of ac is on the left-hand side. We want an upper bound on this, and we have an upper bound, so that's okay. What about the right-hand side? The right-hand side, we know d of ab is less than or equal to max of d of a and d of b. Moreover, we also have d of bc is less than or equal to the max of d of b and d of c. Let's see if I can fit this here. All right, so so that does imply that the max of d of ab and d of bc is less than or equal to the max of d of a, d of b, and d of c. Okay, so look at your inequality signs here. You've got d of AC is less than or equal to, if I could give variable names, perhaps, we'll call this, could I edit? Okay, just for ease of reference, and we'll call this y. And you are quite correct also in noting that we have x less than or equal to y is true. So that is true. But the inequality, if you want to take a look at your inequality signs here, right? You've got d of AC is less than or equal to x. So we'll call this the left hand side. Left hand side is less than or equal to x. Right hand side is less than or equal to y, and x is less than or equal to y. The issue here is that this does not immediately imply that the left hand side is less than or equal to the right hand side. Does that make sense? So be careful. Inequalities are quite tricky because you always have to watch out for the sign, which sign the inequality sign is in. So oftentimes, yeah, your proof would be correct actually if you could show that the upper bound is attained under certain conditions, and you can also work it out when it doesn't attain the upper bound, and that's where Julia's elaborations on when we actually have equality does help here. But if I could, there's another way that you can actually do this here, which is we'll apply 5a soon, but not immediately, but we'll apply it soon. So this is what we'll do. So let's write out the definitions of d of AC, d of AB, and d of BC, as in we want to show that d of C minus A is less than or equal to the max of, I'll deliberately write this as, what should I write it as? B minus A and d of B minus C. Okay, it doesn't matter if it's B minus A or A minus B. Oh, is this? Let's see. 5C. Very good. So I'll do 5A. I'll explain this 5B, and we'll get to 5C. So this is the problem statement of 5B rewritten. We want d of C minus A is less than or equal to the max of dB minus A and d of B minus C. Now, can you see how you can apply 5A now on 5B with this statement here? So the way you can apply 5A to 5B here is notice that d of C minus A is equal to, so d of C minus A is equal to the distance between B minus A and B minus C, because the difference of B minus C and B minus A is C minus A. So this now simply tells you that your d of C minus A, which is this, the distance between B minus A and B minus C, is by 5A less than or equal to the max of d of B minus C and d of B minus A. By the way, when you're writing this up, maybe the best logical sequence to write this up would be, you would say perhaps that d of B minus A, B minus C, so this is just a mock-up write-up, is equal to d of C minus A, or I suppose you could put this in front. So d of C minus A equals d of B minus A, B minus C, which by by 5a is less than or equal to the max of d of b minus a, d of b minus c, and then you can translate this back into d of ba, d of bc. So you could say something like d of ac equals that, which equals, and on the right hand side, this is less than or equal to the max of d of ba and d of bc as desired. So, all right, good. Let's take a look at 5c. So we want to prove the triangle inequality. To direct message, I can take a look at it first. So d of AB, max of d of AB, d of BC is less than d of AB plus d of BC if and only if A is not equal to B is not equal to C. I believe that's correct. If one of, although you can have A equals C not equal to B, so that is a case that is possible, but nonetheless, so d of AC is less than d of AB plus d of BC, which we proved correct. Okay, so this looks correct. Look, I'll paste it here. So, oh, sorry, wrong paste. Undo. Okay. All right. So, text. Oh. So the max of d of A, B, and d BC is less than. All right. Sorry. Max of d of A, B, d BC is less than their sum, if and only if at least one of them is positive. Correct. So d of AC is less than less than or equal to their max, which is less than their sum, which we proved in B. Let's see. Although, so I think let's see. If A equals B but does not equal C, then d of AB equals 0. D of AC equals d of BC, correct. So d of AC is less than or equal to d of AB plus d of BC. Correct. If A equals C but not equal to B, then d of AC equals 0. Essentially the same thing, right? Sorry, not the same thing. Wait. If A equals B, what A equals, all right, not the same thing. Okay. If A equals C but not equal to B, then d of AC equals 0 and d of AB is positive. So okay. Very good. So I will note that you don't have to actually divide this out into cases of if A equals B not equal C, or if A equals C not equal to B. What's asked in problem statement is just less than or equal to. So you don't actually need a strictly less than sign here. Simply a less than or equal to would suffice. So max of d of AB, d of BC is less than or equal to d of AB plus d of BC. And this is because all distances are non-negative. Yeah, simply all distances are non-negative. This always holds. There are no exceptions. So d of AC is less than or equal to d of AB plus d of BC. So that actually just suffices here. Yeah, I'll take this, I'll remove this here, but very good. Now 5D, the culmination of actually all the observations you guys have probably made when attempting 5A to 5C. All right, 5D. What about 5D? All right. What is the property of all triangles in Armolopolitan? Well, to see this, I think I'd like to bring back one of the responses for, I think, A, if I could. All right, here we go, I think. So, case one, if second part is not divisible by 3, so okay. All right, so I'll copy back what Julia wrote for 5A over here. Oh, wait, whoops. All right, so if we revisit this, then, well, there are two cases. First is that A and B have their d of A is not equal to d of B. So the largest power of 3 that divides them are different. So if m is not equal to n, then, well, yes, without loss of generality, we'll assume m is greater than n. Then the maximum of their d of A and d of B is 1 over 3 to the n. Clear. And the distance between A and B is equal to 1 over 3 to the n. Yes, because you factor out 3 to the n in their difference, and the rest is not divisible by 3. We also had case 2 here, which I'll also put up. Case 2, if m equals n, then, okay, let's see if we can fit this. Oh, I've got 2 5Ds. Did not that just was hidden by the chat box. Okay, let's see if I could condense this. See, new message. Yes, and I do received a private message. Correct. So the property of all triangles is that they're isosceles. Very good. Which this is exactly what I was aiming to get to. So indeed, you can see that in this case, we're going to look at A and B as two of the differences between the points. So A and B are not the vertices themselves, but they're the differences between the vertices. Essentially, it's a equivalency of what we did in 5B. In 5B, here we took a look at the differences. So A and C was is this an old? Oh, it looks like this was the old version of 5B. All right. Looks like what I wrote for 5B is not here anymore. But if you recall, for 5B, it was an application of 5A because A and B were the differences, or two of the differences between the vertices. And it turns out that the other difference, there are three differences, right, between 3 numbers. 2 of the differences are A and B. It turns out the other difference is A minus B. So over here, d of AB, what we want to show actually is that d of AB is going to equal either d of A or d of B. The reason this is true is, first of all, in a case that, yeah, okay, I'll cover up what we have above. Maybe I'll change the color for clarity's sake. So, do you guys still see the blue text below, or is it covered? Because for me, it's covered, but I'm not sure what you guys see. Covered. Okay, good. So back to here, we two cases. If A and B had different largest powers of 3, then the distance between them is equal to the max. So it's isosceles in this case. In the case that they have the same largest power of 3, then well, d of a equals d of b, right? Equals 1/3 to m, and that already tells us that it's isosceles. In both cases, they're isosceles, and that proves it. Very good. All right. So we are out of time, and at the end of problem 5 is a fairly good place to stop, I think. You guys, if you guys are curious, you guys can continue looking at the rest of the problems. Meanwhile, I can upload the solution manual to the chat here, so you guys can see. It'll take a minute, but hang on here. It's crashed. Oh, we're back. Suspect it's overloading my computer's memory, but here, I'll close this. See if I can okay, hold on. Server cannot process the request because it is malformed. It should not be retired. That's all for 10 error. All right, never mind then. I can upload the solutions to Google Classroom later for you guys to see. But meanwhile, thanks very much for coming. Thanks very much for participating. Good luck tomorrow. And if you're participating tomorrow, have a good day, have a good weekend, and don't sweat it. Okay, just enjoy yourselves. And thank you very much. So.